Hey, I just wanted to go through that last example that we went through, and I might do another one just to show you another possibility. But this was the one we were talking about with the group of 1,000 that was split into the two groups of 500. I just wanted to show you the details of what I would write down for that solution in the free response. So I would start out by defining my two proportions. So I have two samples. They're each 500, but I've got a total sample of 1,000. So I have P1, which is the proportion of those that were given the low-dose aspirin that developed cancer. The second proportion is the proportion of those given the placebo that developed the cancer. So we're going to try to compare those two things. So here's what I would have for my hypothesis statement. Okay, so here, my first hypothesis is that they're equal. Okay, we're assuming that aspirin doesn't do any effect, it doesn't do any good, it doesn't change anything. P1 is equal to P2. You can put that as your hypothesis, or you can also write it P1 minus P2 is equal to 0. Either one of those give the idea that they're the same. There's no difference, they're equal to each other. My alternative, which sometimes is put as HA or H1, either one is fine. You've got an alternative hypothesis that the ones that are given aspirin are going to make that proportion smaller. So P1 would be minus P2. Or it's also written P1 minus P2 is less than 0. Okay, so that's my alternative hypothesis. Well, then I go straight to the next step is I have to go get a sample. Well, they gave me the sample information. I did one, P1 hat was 15 over 500, P2 hat is 26 over 500, but then my PC, which is combined, I want to calculate all three of those before I even go into any formulas, right? So I've got those three. Now I can go straight into my formula. Well, my formula says my Z is my statistic minus my parameter divided by the standard error. What is this one? If we go to the formula sheet for a difference in proportions, it looks like that, okay? Most of the time, we're looking at two proportions and we're saying they're equal or we're saying they're different. So that parameter there, remember that's in the null hypothesis that the difference between those is equal to 0. You could very well have a hypothesis test where somebody says the difference in these groups, we already know there is a difference. It's different by this amount. It could have a number there. And then you're trying to prove that the difference is either larger or smaller. Most of the ones you're going to see in this class, they're going to be equal to 0. So that's why we have that minus 0 there for the parameter. My statistic is the difference in those populations. And notice in the standard error, we've got the population, the sample proportion for the combination of those two samples, right? If you do those calculations, we end up with this. So we have 0.03 minus 0.0525. You can pause it and kind of do your own calculations and compare what you will get in those calculations. We should get a Z value of negative 1.754, which if you look at it being a less than for the hypothesis, for the alternative, it's a left-tailed test, which makes sense that in this normal distribution, it's going to be on the left on that normal table. So if we look up 1.754 in the table, well, actually, if we try to make it really, really accurate, we could look up 1.75 and then we could put 1.76 and look at those values and see if we can get a value right in between. Well, right in between, we can round to 0.04. So if you look at the tail to the left, that's your p-value. That's going to be equal to 0.04. Now let's take a look at the alpha. The alpha was 0.05. In order for a tail to have 0.05, it has to be bigger than this 0.04. So I've kind of drawn a dotted line here to show where the alpha area would be. And I actually looked it up in the table and it's negative 1.635, which makes sense that it would be on this side of negative 1.7. So we've got our value further out than our significance level allows. I've found more evidence then having something in the middle. Essentially, I've found the p-value to be less than my alpha. Now I can conclude we do have enough evidence to reject the null hypothesis. Thus, the conclusion in real terms to this particular problem is that the aspirin does in fact reduce the chance of cancer. So hopefully that helps. That's the beginning, the hypothesis setup, grabbing the statistic, getting the calculations, finding the z-value, finding the p-value, comparing it to alpha, and then also putting in the conclusion statement at the end. You're going to need all of those pieces for anything that says that I'm testing to see if something's true. So I'm going to try to grab another one just as another example, just to send that over to you. We'll see if I have time to get that to you sometime soon. Thanks so much. Bye.